Hey everyone, back. Where were we? I had to take a little bit break. So we were discussing about asynchronous calls v2, which is coming with RC 1.6, closely after XDay. The idea is that parents will register a multitude of asynchronous calls, and in each call they can define the callback function and the minimum guess they want for those callbacks. This means that developers do not have to worry anymore about whether there is enough guess for their callback or not, as they are the ones who define it. And in the callback, they can do whatever they want. In general, it is a good idea to write your callback in such a way that it doesn't yield an error, but it writes to storage. The asynchronous child calls, so the parent registers all the calls and executes everything around after it, whatever he has in that kind of function. And when the smart contract execution of the parent finishes, we start and execute one by one all the asynchronous child calls. The asynchronous child calls are registered in order, and they are executed in order intra-shard and in order cross-shard. But this actually means that if you have a cross-shard call first and an intra-shard call first, the intra-shard call will execute it first, and then because of how cross-chain smart contract communication goes. But you can easily optimize this kind of executions beforehand in order to know the order you want to execute. And here is some good ideas. If you want to have asynchronous calls to be executed in the same order, independent whether they are intra-shard or they are cross-shard, we can do that as well, or at least to do the callbacks in order that well. This might come in asynchronous calls v3. Each callback function is called the parent, and the parent smart contract can read the status of all the callbacks and asyncs he launched before for that execution environment. After the last async callback is done, the VM closes the storages of the asyncs and the closure is done. One level async call is enabled in async call v2 in order to not get into inconsistencies between intra-shard versus cross-shard transactions. And these kind of things we want to resolve on asynchronous calls v3. But we will discuss a little bit later about this. One big topic on MultiversX, why it is so easy to build, it's because the token standard which is implemented at the protocol level. I cannot understate these kind of things when comparing how easy it is to do complex or simple DeFi operations when you know that you do not have to interact with smart contracts, but payments come in the form of ESDTs and payments are handled at the protocol level. There is a complete other presentation about ESDTs and all the properties. You may check that as well out. Here I will talk about generalities. So we have fungible, non-fungible, semi-fungible, meta ESDT tokens. And the thing is that they are composable by default. One extremely important thing is that in case of any error, tokens are returned back to the sender. That sender meaning the smart contract, that sender meaning the user. So in case of any error in the flow of the execution of multitude of smart contracts, token transfers are reverted, and this revert is done by the protocol itself in a safe manner in case of errors. So it is pretty safe. You do not have to care about sending back those tokens if you have some errors, because you can just throw an error and those tokens are automatically sent back. One important thing to note here is that we implement the paradigm of transfer and execute, which is like light years ahead of the model from Ethereum, EVM, the ERC standard tokens, which are, by the way, mostly the same in all EVM compatible chains. Those tokens, ERC20, ERC721, ERC1155, they implement the approve and transfer from functionality. This means that I, as a user, have to give an approval for a smart contract to use and transfer from my account some tokens out. This is happening because those tokens are kept at the smart contract level, all those tokens, and not at the protocol level like we have in MultiversX. And that's like changes the perspective completely. What do I mean? If you look at around on Ethereum or on other chains, you will see a lot of draining of funds. What does it mean? It means that you have an Ethereum account and you see a post on Twitter with some kind of airdrop of $10, $20, $100, whatever, scam link. You click there and you see a transaction to be signed which doesn't seem malicious at all. Allow. What does it mean? You just never know. And or whatever transaction you sign and it goes into a malicious smart contract. What the malicious smart contract do? You actually allowed your tokens to be transferred out from your account into a smart contract. And you are not only allowing this to do for in general, these kinds of malicious contracts do that you allow transfer for a bunch of your tokens. That's how they do it. And it's pretty wrong to do kinds like this, but like no protocol can protect you against it. Not USDC, not Wrapped Ethereum, not tokens, what you have there. And it's a little bit kind of stupid. For example, if I own USDC and I want to swap to Wrapped Ethereum, first I have to approve the Uniswap smart contract to take tokens from my account, one transaction. And on the second transaction, I will have the execution of the swap can be called. It's okay when you have two tokens, but for example, when you want to add liquidity, it's already 3 transactions. Or 4 depending on the case, but let's say 3. You have approved for USDC, approved for Wrapped Ethereum, and then the actual add liquidity. What these kind of smart contracts and front ends do is that they actually make you approve infinite number of token transfers from your contract, from your account, and then on the next iterations you will be able to do the swaps with only one transaction. As you may see on MultiversX, you need to sign with transfer and execute. One, the user is much safer because nobody can drain funds from your account. There is no transfer from. And secondly, you can just simply multi-transfer your tokens to a smart contract, and the smart contract will handle it under it. And if anything fails on that, all those tokens are returned back to you. So that's why it is simple. And later on we will see how simple it is with Position Creator, where we can do multitude of actions atomically and build up complex positions for a user from a single transaction without the need of calling approve and transfer for multitude of contracts. What is more with ESDTs is that all token management code is at the protocol level. This means mint, burn, create, set transfer role, transfer role. And we built common Rust modules on the Rust SDK to manage all kinds of token management, every kind of token management. So what you need to do as a developer, you just import the module and it abstractizes everything around what happens around under the bridge. So you just have to call an issue, and in the backend, it will make an asynchronous call to the meta chain ESDT smart contract, but you just do not care necessarily about it because it's underhand, and the callback is handled as well. Everything is like with simple end interfaces, and every kind of execution to another smart contract, which was previously discussed, can be done with transfers or without. One super important thing, and this is again why it is easy to build a MultiversX, is the multi-ESDT NFT transfer. Again, super important innovation, and we take these things pragmatically. Like how it was multi-ESDT NFT transfer developed. We were like working on the first DeFi automated market maker, and it's so okay. If I want to add liquidity, I need to sign at least 2 transactions, because I had to add 1 token in a pool and then add the second token and call to pair it with my firstly deposited tokens. Come on, it's not so good for the user, for a user. So what can I do? Let's build multi-ESDT transfer at the protocol level, and it's resolved hundreds of issues, and it made the UX, all the user interfaces easier, and it made all kinds of development of smart contracts easier. So what you can do right now, you can have a proxy smart contract in which the user, for example, multi-transfers 5 tokens or 10 tokens and says for that proxy contract that, okay, with the first 2 tokens do this, with the next one do that, with the result from the first 2 at the execution and combination with the rest of that do that. And all this atomically. And if anything on the process fails, your transactions are returned. How cool is that? It's like to do that in an EVM style, EVM compatible or EVM style blockchain interface. It will be super awkward. First, you have to approve. You have to approve for that proxy contract to take all your tokens. Second, you have to call approve from your proxy contract to all the contracts you want to interact with, that those contracts can take tokens out of the proxy contract, and then for all the results they have to have all kinds of approves, and then only to do the transfers, and you can transfer only 1 tokens per stuff. Only for ERC 1155 you can do multi-transfers, but then only for the same token IDs. It's not for complex token IDs. Like here in multi-ESDT transfer, I can pair token IDs from different issuers, from different, like USDC, wrapped Bitcoin, wrapped ESDT, Atom, HSwap. They are all from different issuers, and I can combine those together into one call. Another important innovation which is coming with RC 1.6 is the concept of back transfers. And the back transfers came from the idea of like building base smart contracts and making sure that those smart contracts are safe and can handle anything, even if they are called by bad or, let's say, buggy smart contracts from the top of it. So we were, a base smart contract, like a liquidity pool smart contract, you call it, you swap something, and the liquidity smart contract will transfer the tokens back to the caller. And this transfer is simple. If the caller smart contract, for example, is non-payable and does this kind of swap, it will yield in error. So this parent smart contract will have an error because on the transfer function from the liquidity pool contract, we will check that it is payable, and I am just transferring simple. This is a non-payable smart contract. Let's kill the execution. And because of this, if you have like a function in smart contracts like in bridge, where you get multitude of actions together, and then you want to do transfer for all those actions, transfer all those tokens to different addresses, and then one of the it's like a smart contract written in such a way, then it would crash. And there were some other limitations like this. For example, in liquid staking smart contract, how it was written in some of those, and even in our version of like the first version of liquid staking contract, which was open source for everybody, if a wrong contract would call unstaked liquid staking contract, and then the liquid staking contract would do an asynchronous call to the metachain ESDT smart contract, which comes back to this to the liquid staking smart contract, and the liquid staking smart contract would actually the unbound function, and the liquid staking contract in the callback would transfer the tokens back to the initial parent, which was this wrongly written code, which is a non-payable smart contract. It would fail. And as it would fail, the callback will fail, and all the storage rights in the callback would fail. And this would have yielded in invalid state at the liquid staking contract. So the liquid staking contract would have to implement special things in order to resolve these kind of back transfers from wrongfully written contract. Because of this, we decided that we can implement back transfers. This means if a parent contract calls a child smart contract and that there is a transfer from the child to the parent, even if it is a transfer after a callback or all kinds of in term of the execution of the child, there is a transfer back to the parent, we accumulate all the transfers together and there is no check for payable. And then the parent contract can have access to all these payments through a new endpoint, which is called managed get back transfers, and he will see all the payments. This ensures two things. One, it's easier for you to write a contract, for example, on top of the liquid staking contract, and the liquid staking contract doesn't have to make transfer and execute some function what you want as a, let's say, as a parent contract to be executed. It doesn't even know that because it doesn't have optional arguments to send it back to you. There are no necessary to build hooks, and then you can see all kinds of back transfers you received. So everybody is safe on this side. So what we see it gets even easier to develop. And one thing with all those kinds of ESDTs, it is easy to wrap one token under the other one. You can check how we build the farm contracts, the proxy DEX contracts, all kinds of contracts. Like I can come with two tokens, I send it into the LP, and the LP will give me a representation of a new LP token. With that token, I can go and call a farm contract. And the farm contract doesn't know about the liquidity pool contract. He knows that he can receive this kind of token ID, and he keeps in the smart contract balance that token, and we'll give a representation of that in form of a farm token to the user. And furthermore, that the user with the farm token can go to the meta staking contract and do the same. The user will leave the farm token in the meta staking contract and will get a representation of the meta staking contract of the meta staking token ID, and on and on and on. So the funny thing is that neither of those contracts have to know about each other. They have to know about the token ID, which is cool. And even if we go forward there with a farm position or a meta staking position, I could go into lending, for example, on Atom, if Atom enables this, and Atom can enable it by whitelisting only the token ID. They do not have to know about the farm token address, how it is created, why it is created, what are the functions of the farm token. Nothing is needed. You just need the token ID, and it's wonderful. One super important thing about ESDTs is that they just prevent one of the most usual attack on smart contracts on EVM chains, meaning reentrancy. There were like hundreds of reentrancy issues, and like a lot of funds were lost. Even later, right, a few months ago or in the summer, there was an issue discovered on that Viper, which is a smart contract language on EVM, which is used by Curve, Balancer, and others, that had an issue with the reentrancy lock function. And this reentrancy lock meant that a wrong state was locked and unlocked. A reentrancy lock in case of EVM means that you save something into a storage before calling even a transfer from. As you know, the transfer from function actually needs to execute a smart contract. And if that smart contract is a malicious smart contract, and in general there are a lot of malicious smart contracts, like a malicious ERC20 token smart contract, you as a base smart contract, you never know that the other one is malicious or not. The malicious smart contract, in the transfer from, they will inject another execution back to the smart contract. So you get like loops of reentrancies, and then they can drain the funds from the base smart contract. And for these, there are a lot of hardcore protections, reentrancy locks, and you saw even in something like called reentrancy lock, there was a bug, and then the most important projects lost millions of dollars. So it is bad code. Right now, what you see here, it is the only one you could do which is exploitable by reentrancy. And it's like pretty hard to write such wrong code. The idea is that you want to swap token with extra arguments. So you allow that, okay, I swap your tokens and I will call transfer and execute, and I will execute whatever you send to me. So you compute everything, but you do not write to storage at all. You call transfer and execute with the swapped tokens and with some extra arguments. And here the malicious contract, which called you with the extra arguments, calls swap again. This means they can drain the funds because the computation of the swap was not written in the contract, so they will swap with the same price as at the first iteration, and they can do a few times like this. And then you write data at the end, but all your internal storage will be messed up. So you see that you will have to be like a base contract which actually allows like execution after my functions. Nobody is doing call like this in MultiversX, and with the back transfer you do not have to do extra arguments. You will not allow at all extra arguments. So building contracts which is exploitable by attacks, it's pretty hard. On future releases, we have a lot of targets. We want to make smart contract interaction easier. That's why, for example, the back transfers implementation for RC v.1 and asynchronous calls v3 make further security enhancement. And one of the security enhancement we want is, for example, to make the transfer and execute to actually do the transfer synchronously and the execution only at the end of the call. This would mean that execution will be the same whether it is intra-shard or cross-shard, because in transfer and execute, when the destination was cross-shard, it was always the execution was done at the end of execution of the current smart contract. We want to make developers to build easier and to use like DeFi blocks or existing modules and build on top of it. And building on top of DeFi contracts is easy right now, and it will be even easier with the back transfers implementation, for example, or asynchronous calls v3 and v2. We already have like interfaces, common modules, token wrapping. We have how to deserialize ESDT attributes, everything like that. If you look at all our building blocks, you can check it on the MultiversX GitHub. We have subscription contracts. Right now we will have paymaster contracts, exchange tool contracts, like to create different kinds of positions with only one transaction, and even auto-fart contracts. One of the things we want to work, and we are working right now, is a proxy contract, which would enable for a user to execute multiple operations atomically. So this you would deploy in the same shard where you want to interact atomically with multiple underlying smart contracts. Then the user can call it from wherever it wants with a multi-SDT NFT transfer, say for the proxy contract what kind of executions do they want, and all is executed for them. This is like an example, it's with the position creator smart contract. In the position creator smart contract, I can have, for example, only EGLD, and say for the proxy creator contract that I want a meta-staking position of EGLD right. This means that first the proxy smart contract will swap half of my EGLD to right. Then it will enter into liquidity pool, it will enter into farm, and it will enter into staking. And this, the user will have to sign only one transaction. The proxy smart contract does these all kinds of things atomically. And if any of those steps fail, then the user will get back his EGLD directly. So building on the existing DeFi is pretty easy, and all those farms and staking, they have interfaces. So next things are again pragmatic improvements. What we see, we build, we use, and whatever common modules we want others to use and others to feel safe and build safer, then we rather build it in a module or rather build it in the VM or in the protocol side. So I already said about the transfer and execute that will only transfer the tokens at first and run the execution at the end after the smart contract execution finished. This will completely eliminate re-entrancy code, re-entrancy possibilities. So you will be completely safe with using the transfer and execute functions. Even right now, you just have to put the transfer and execute at the end of the smart contract, but we will help you even with this one. A new thing will be like get relayer address on a VMI endpoint, especially for paymaster functionalities. ZK proof verification API on VM directly, so you do not have to write your own ZK Rust library and audit it and verify it and do all kinds of things. You just will have to call a verified API. A new thing is like execute on by original caller and by callee. This will be done in a subsequent release. But you will be able to launch from your contract. You will be able to execute further in the name of the user or in the name of the caller. But the base smart contract has to be prepared for these kinds of smart executions. For example, in X Exchange, where we have the energy contract, we can enable contracts to execute by original caller. And this means that there is no impersonation, like the user will sign that transaction, which will do some stuff for the user. And then you will be able to build easier proxy contracts on top of other contracts where there is user information inside the smart contract. One fun thing we are working on is to make like dynamic execution, a small interpreter for user operations, in which from the transaction data, a small new language, we could say that, okay, the user wants dynamically to be executed this in this kind of steps. We are still working on the details, but it will be like, in case of these, all kinds of proxy execution will be able to be generalized. Only one proxy smart contract which executes multitude of actions for the user, and you will be safe. Now we get into asynchronous calls v3, which will be launched, which we are working on, and it will be launched in a subsequent release, and this will achieve the dream of fully sharded agnostic smart contract development. It will be mostly the same. For example, for smart contract developers right now, we use asynchronous calls v2. It will be exactly the same, register async calls, but what we do is that child contracts can register further async calls as well, so multi-level async is achieved, and the parent smart contract will get the accumulated result. So if a child smart contract made asynchronous calls further down the line, as a parent, you will see the execution of the child and the execution of all the callbacks of that child, and whatever it sent to you back in a standard structure, and you will be able to read from that. And all the transfers from child smart contract to parent smart contract are registered as back transfers, as it is with the new implementation. And the parent smart contract will see everything as accumulated payments. So multi-level, multi-async is enabled. Composability is a big thing on how do we use and how do we build systems on a blockchain. And composability in MultiversX is easy through the power of the tokens. So all DeFi information can be tokenized, no need to keep balances at the smart contract level like in ERC20, no need for approve and transfer from, we really hate that. And then you can have all kinds of positions from LPs up until to multi-yield farm token LP. Smart contract, you have to develop only like once your smart contract, and you can accept multitude of tokens, and you do not need to take care about who and what kind of smart contract created this token and what kind of attributes it has. Like the liquid staking smart contract, it's actually a representation of the staked values inside the meta chain system smart contract, a liquid representation, a tokenized representation of one's position. You can use that and go into a liquidity pool and start a liquidity pool and put into a liquidity pool. The liquidity pool contract doesn't need to know about doesn't know at all about the liquid staking smart contract, doesn't know about the staking contract at all. And then you can go to farm, to lending, to borrowing, and there is no direct interactions of smart contracts to smart contracts, only token operations. And by doing this, you see that all smart contracts built like this are like shard agnostic, because they are working with these kinds of tokens, with multi-transfer or non-multi-transfer, but they are safe. So one can use in the lending, the same lending smart contract with different whitelisted tokens. And no, you don't need to do all kinds of integration like balance off. In case, for example, in Ethereum, a lot of smart contracts, DeFi smart contracts have to and are calling balance of user address on another smart contract to know the balance of the user address, and all kinds of complications like this. You are receiving the payments from the user. You can see the payments, check the payments, verify those, send back to the user, or like return an error, and the protocol will resolve all the sendbacks. So, and because of this, building proxy contracts on existing DeFi products or building other DeFi products on existing tokens, it's easy. You don't have to know the details about the DeFi contract. You just use the token ID inside your contract, you whitelist it, and it's fun. You can see all these kinds of tools in MX Exchange tools: auto position, multi-yield farm, auto farming contracts, even with the energy contracts. Router contracts like Ashraf V2, which use multitude of other DeFis as well. No other blockchain offers so much, like built-in token standards with so high efficiency, customizability, security, and like built-in composability at such a level. We can generate, for example, ABI directly from the Rust smart contract, and that ABI can be used for front-end to integrate that. And even generate interfaces and generate and define another smart contract you are dependent on as an object, like from object-oriented programming. And then at the compilation time, you see whether you have a problem on the integration or not. So here we can see an example of the farm proxy contract, in which underlying here we define the farm proxy. We get from a storage according to its address the farm contract. It's actually an address we are getting, but we define that as a proxy for the farm with load rewards contract, and we do farm proxy exit farm endpoint. And if we call this endpoint with wrong arguments or stuff like that, it will fail at compilation time. So integration is easy. And then we can go over for more common interfaces like the a module or an interface for a common pause functionality of a smart contract. You have a big smart contract and you want to call the pause function from another smart contract, and you need to define only those functions you are interested in, like pause and unpause, and you call this as in object-oriented programming, where you take the value and you take the object and you execute a function on that object. The same with like price provider. You directly declare it and you set the endpoint name and how the endpoint is defined. Actually, this information is verified at compilation time if this kind of definition is correct via the GitHub commits. And then when you want to get tokens for given position with safe price, you get from the storage the address as shown before, and you receive a smart contract object, let's call it like that, in which you execute whatever you want. And what we saw more is that we are building we started to build a few smart contracts which had a lot of base code, which could be used for other purposes. So we started to use modules. And in case of modules, the developer have to import only the module and use the functions as he wants. So one of the examples is a claim rewards function module. This, for example, if you have a smart contract which is owner of another smart contract, you have to call the claim developer rewards function to gain the rewards. We integrated a small module which does exactly like that. And you would need only to import the claim developer's rewards module, and this kind of function would be already accessible to you. We have multitude of modules like ESDTs, like integration with the staking or delegation smart contracts, DNS, transfer role proxy, user storage management. And a lot for the DeFi modules, like in swap, farm, stake, computation of the rewards according to rewards per share. All those are modularized and you can use on your contracts. And you can use all of our contracts. Modules in general are standard, are verified and are audited, not all, but you do not need to rewrite them. You can just use it, and you do not need to for example, to call a library smart contract to do something for you. With modules, everything is inside your contract. You control it, and the gas is cheaper. You just import and use it. For example, here in the position creator, we just import a lot of modules like farms, meta staking, storage, read modules, auto farm config modules, actions modules. For example, by importing the meta staking storage read module, you would import all the functions which would deserialize and the attributes which the meta staking smart contract creates for a user. So you would understand the attributes, and you would get, for example, from a storage read, you would not only get a byte array of I don't know what, and I have to write the deserialization lines of code, but you would get an object of those things deserialized. And you can use directly the meta staking token object as it is, and you can operate on it. Oh, I think we reached to the end of our discussion, and I would finalize with one big food for thought. Developers, smart contracts actually are getting a 30% royalties. What does this actually mean? For all the transactions which got into your smart contract, the 30% of the fees remains in the smart contract as a developer reward, and the owner of that smart contract can always claim those rewards. If you look around for the most used smart contracts on the MultiversX ecosystem, you will see few thousands or more EGLD and developer rewards for those contracts. So you have to build a successful smart contract, for example, a proxy which everybody uses, and then you will receive a lot of rewards. I think this incentivizes a lot to build smart contracts on MultiversX. And thank you very much. It was a long talk. Hope you can enjoy everything. And if you have questions, please ping us. And we are constantly trying to build more and more, constantly trying to improve our tools, and we are making smaller, bigger improvements in order to help the whole ecosystem to resolve issues and to enhance development with security, scalability, and user perspective in mind, developer perspective in mind, in order for developers to build easier. Thank you.